I love engineering design, entrepreneurship, and education, and that's why I came to the Atlas Institute.
Hey everyone, my name is Cody Candler, and I'm a master's student in the Creative Technologies and Design Department of the Atlas Institute at CU Boulder. For me, there were actually a lot of twists and turns in the path to getting to this program.
In undergrad,
I had taken a position as a learning assistant for one of the physics courses at CU, and I had never seen myself as being a teacher, but I walked away from every recitation that I taught feeling really excited and energized, and it was always the highest point of my week. And one of the requirements for being a learning assistant for these courses was that I had to take an introductory education course. And as the course came to an end, the professor suggested that I keep studying education. This led me to finding the Engineering Plus department at CU, where I was able to pursue a teaching license while also studying structural engineering and having a nice thrown in splash of engineering design. When I was looking for a master's program to combine my passions for engineering design and education, it was obvious that the Atlas Institute was the right place to do it. Atlas offered the flexibility for me to study the areas where education and technology intersect. And that flexibility ended up being even more important than I expected. Because the summer before I got into my program, a group project from undergrad was accepted into Catalyze CU, which is CU's summer accelerated program. This helped me launch my company, EdBoards Technologies, and it also gave me a bit of the entrepreneurial bug. So when I started my master's program that fall, I had 3 areas that I was focusing on: product design, education, and entrepreneurship. Every time I learned something new, I took it and applied it to my work at EdBoard.
which helped us refine EdBoard from a prototype like this into a consumer-ready product with thorough user testing and a streamlined manufacturing process.
This culminated recently with me pitching my way to the finals of New Venture Challenge. While the coronavirus pandemic meant that we didn't get the opportunity to pitch live at the Boulder Theater, our digital pitch was definitely an interesting experience, and in the end, we took 4th place out of 146 original teams. And to give you an overview of what we've been working on, here's our New Venture Challenge finals pitch. Hey everyone, my name is Cody Candler, and I'm a master's student here at CU Boulder studying educational technologies. And a few years ago, while I was teaching at the Denver Schools of Science and Technology, I saw something. Some of the brightest students were struggling with their coursework, and some of those students who had a harder time with the same content were consistently getting A's. Confidence was the thing setting these students apart. The belief that they could succeed and belong in science, technology, engineering, and math. Fortunately, we have an opportunity to help children develop confidence with STEM. Because from the ages of 5 to 11, children are at a developmental stage where they are establishing their foundation for confidence. And when a child is confident that they can succeed somewhere, that is a launching point for future success. And that's why we founded EdBoards Technologies, an edtech company that is dedicated to helping children develop confidence in STEM during that pivotal age of 5 to 11. We're focused on the area of STEM education where we saw the worst accessibility for children, electrical engineering. We're fixing this through the help of our hands-on circuitry kits. And we started by redesigning an industry standard tool. This is a breadboard, the industry standard in circuitry design. It allows you to quickly design and assemble circuits. It's the main tool being used to teach the fundamentals of circuitry. And electrical engineering employers would expect you to know how to use one. Unfortunately, it isn't intuitive, and because it requires fine motor skills, children struggle to use it. So we wanted to develop a tool that could imitate the beneficial properties of a breadboard while being optimized to teach children ages 5 to 11. And that is why we made the EdBoard. We kept the same form factor as a traditional breadboard so that skills developed with our kit are directly transferable to the breadboard. We developed electronic components with magnetic connections, adding a fun, tactile experience for the students. And we made our board spacious and transparent so that children can develop a conceptual understanding of the circuits they build. Now, from talking to parents and teachers, we learned that hardware on its own isn't enough. Children need lessons that are creative and engaging and challenging. So we developed insertable story cards that are coupled with story-based lessons that engage students in creative problem solving. Best of all, these stories offer an exceptional opportunity for parents to work with their children while the learning happens, vastly increasing what a child can take out of the experience. Now more than ever, we're reminded of the importance of flexible learning solutions that can work with a variety of scenarios. We've tested our kits with over 700 kids, plus parents and teachers, and while doing this, we're also running an academic study to see how kids learn with our tool. And the results have been amazing. We're at a point where kids absolutely love using our product, Parents are constantly asking us where they can buy it. And educational organizations, like after-school programs, are directly telling us that they would buy our product because there is nothing else out there that meets their educational needs. So why are our customers getting so excited about EdBoard? Well, our competitors all approach EdTech in one of two ways. Either they make an exceptional engineering tool that is frustrating to use for children, or they make a really fun to use toy that doesn't teach real engineering skills. We win in this space because we combine real engineering education with accessible, tactile fun. And we know we're succeeding here. Because in a study with 20 children, we found that every single kid who used an EdBoard said that they wanted to build more circuits in the future. And children who used EdBoards learned the same content 4 times more quickly than children using traditional breadboards. Could you imagine if schools could teach a subject 4 times more effectively? Now, because our product works so well for getting kids excited about STEM, and parents are lining up to buy it, we've refined our prototype into a production-ready model for our Kickstarter. This will allow us to ramp up production, receive market feedback, and build brand awareness. Following our Kickstarter, we'll be selling our base kits online, competitively priced at $39.99. And of course, no parent likes a toy that is designed for short-term use. That's why we offer our online educational materials and engaging expansion kits that can be purchased individually or through our subscription service at a discounted rate. Our goal is to get 200,000 EdBoard kits into the hands of kids in homes, schools, and after-school programs within the next 3 years. Funding we received through New Venture Challenge will help us to surpass that goal by financing marketing, manufacturing, and key hires. Our team of dedicated engineers, entrepreneurs, and educators are combining a technical expertise with a passion for what they do to develop creative solutions that are getting kids excited about STEM. We are EdBoard, and we are so excited to change the way that kids learn. New Venture Challenge this year was a huge success for us, but we had actually participated in New Venture Challenge the year before, and we didn't even make it to the finals. So a lot of what I've been working on this year is figuring out where we were lacking in last year's competition so that I could build out the company and get us farther.
We found 3 areas where our company needed to grow: product improvements, our business model, and proof of efficacy. With the help of my awesome co-founders, we made huge improvements to the design of our product. And while some of it had to be over Zoom, my classes really helped us to figure out how our business model should look. So that just left proof of efficacy. Our whole premise was based around EdBoards being good at transferring skills over to Breadboards, and we had no proof that that worked. And that's where my thesis came in. I wanted to do a comparative study to understand how children learned with Breadboards and EdBoards, and whether skills learned during those activities were transferable between the tools. And with a lot of luck, the study turned out wonderfully. My original plan was to do my study in focus groups over the course of a semester, but that changed a little bit when we got an opportunity to do our study at a local event called STEAMfest. This meant pushing my schedule way up and really cramming for my IRB approval, but in the end, it was totally worth it. Because just a few days after getting our data, the coronavirus pandemic hit the US, and that was way before my intended date with the focus groups. So if I hadn't been forced to cram and really push my whole schedule up, there's no way I would have been recording data at all for my thesis. For data collection, I put together a research team of 6 researchers, including myself. Every child who participated was asked to build a circuit on a breadboard and an EdBoard. The circuit had the exact same components and wiring, but the tools were different. Once a child finished their circuit on the first tool, they were asked to recreate it on the second tool. We measured the number of times children experienced frustrations with fine motor skills and with misunderstanding their tools. And we also recorded how long it took for a child to finish each circuit. And the results were really interesting and statistically relevant. Not only could children build the same circuit way more quickly on an EdBoard than a traditional breadboard, but we also can see that the skills are transferable between the two. Because after practicing on an EdBoard, children were way more efficient at building their circuits on breadboards. In fact, the combined time that it took a child to build a circuit on an EdBoard and then a breadboard was less than the time for a child to build on just a breadboard alone, because the child experienced so fewer frustrations. Alongside my co-founder and co-investigator Ruhan Yang, we compiled our results into a work-in-progress paper for Interaction Design in Children 2020. And tonight, as I'm editing this video, I just found out that we were accepted.
Thanks so much for taking the time to watch my presentation.
If you want to keep up to date with what's going on at EdBoard, you can find more information on our website and social media. And I want to give a huge thanks to my advisor Ellen Doe and my whole research team, because there's no way I could have done it without you guys. Thanks everyone.